Okay, so let's start this. And this is the going over a few questions, not all of them. I'll go a few questions on the review. So this is like, I guess, a pre-review of the review sheets because your test is next Friday, so you'll definitely get one or two more of these. Okay, yay. All right, so the first part, or these one of the topics that's you're definitely going to see is combining like terms. There's four of these. I will do one, and I will do eeny, meeny, miny. Let's do one with the over here. Okay, let's do number two. So number two, you see the distributive property. You see the parentheses. You see the term outside. You have to do the distributive properties to get rid of the parentheses for then to be able to combine like terms. So let's do this. Okay, here like this. And then the 3 will be with this, and the 3 will be the 2y. The 3 does not get multiplied by 23 because 23 is not in the parentheses. Okay, so I'll start 20m. 4 times 2 is 8y, plus 3 times 12 is 36m. Careful here, it's a minus, okay? So 3 times 2 is 6y, minus 6y, and then finally just copy down minus 23m. Okay, so that would be step one. Okay, step two, now we're going to identify our like terms so that we can combine, add them, subtract them together. Okay, so there's something here. There's a term with an m. I'm going to circle that. I'm going to circle this guy here because it also has an m, 36m. And remember, you're circling that operation, the addition side that comes preceding the term, right before it. And there's also one more term with an m, and it's minus 23m, so I'm going to circle those two. And the other two, I'm not even going to do anything because they're the same, so we'll just, whatever's not circle, we'll call them just a y. So let's move things around. 20m. I'll move that 36, that plus 36m right next to it. I'll move that minus 23, that's all the way at the end, next to this 36. And I'm going to move the 8y over here, plus 8y to the end. And the minus 6y is going to go to the end as well. So you'll notice that all the m's are next to each other. All the like terms with m's are next to each other, and all the y's are next to each other. So now I can combine 20 plus 36m. Okay, that gives me 56. And then I'm going to subtract 23. That's going to give me 33. So these three terms combined gives me 33m. And then I have these two y's, 8y. If I have 8 y's and I take away 6 of the y's, I'll be left with plus 2y. So there's the final answer, and that's what I'm looking for. Okay, so question number 1 and 3, it's almost as if they don't have to do the distributive property. It's almost as if I did the distributive property and you just got the expression, and now you just got to do this one where you circle, identify the like terms, and so forth, and move things around. Okay, so I'm doing one problem. I don't think I need to do all four. Okay, to get an idea. If you definitely have questions, I'll provide an answer sheet later on for all these problems so that at least you know what the answers are. Okay. 2. So simplify each expression using order of operations. So now we have something called not like the fact that sometimes I've seen some of you guys write this on the side so that you remember. So we have G for grouping. Okay, any grouping, parentheses, practice, parentheses, brackets, absolute values. So those are things that you would do first, and then exponents. Then once exponents are taken care of, you'll do multiplication or division, whatever comes first from left to right, remember. And then finally, the last two operations you'll do is addition or subtraction, whichever one comes first from left to right. Shoot, I don't know which one to do. So let's do 6. 6 has 2. It's a fraction, right? So the idea here is do the top, simplify everything on the top to a single number, do the bottom, make sure everything that gets simplified to one number, and then see what kind of fraction you get and see if you can simplify that fraction. Okay, so let's do that. So on the top, I get 4 squared times 5 minus parentheses 2 to the 5th divided by 2 to the 3rd. So let me just do this. 4 to the 2nd times 5. I'm going to leave that alone. Could I have done 4 to the 2nd? I probably could have. But why don't I actually do that? So it's not going to affect anything. So 16 times 5. Leave the multiplication for later. And inside the parentheses, I have 2 to the 5th divided by 2 to the 3rd. 2 to the 5th is 2, 4, 8, 16, 32. So I'm going to change that to 32. Divided by 2 to the 3rd, which is 2, 4, 8. And all that to the third power. At the bottom, 6 squared minus 5 times 4. I'm going to do the exponents, which is 36. 6 to the 2nd power is 6 times 6. And then 5 times 4. I'll leave that alone for that. So let's see, 6 times 5. I'll leave that alone for now. Inside the parentheses, I'm going to do 32 divided by 8, which is 4. Oh, I forgot the minus sign here. And that's going to be raised to the 3rd power. And at the bottom, I'm actually going to, at the bottom, take care of the 5 times 4. So you get 36 minus 5 times 4. Now, let me bring this over here. So on the top, I have 16 times 5 minus 4 to the 3rd. I still have to finish the parentheses, so let's do 16 times 5 minus, and 4 to the 3rd is 4 times 4 times 4, which is 64. All over, all over 36 minus 20, which is 16. So at the bottom, I can actually do 36 minus 20. Okay. So I know what the bottom, all that equals 16. So on the top, excuse me. On top now I have 16 times 5 minus 64. 16 times 5 is what I'll do, which is 80 minus 64 over 16. Let me change colors again. And on top, 80 minus 64, I'll subtract that, and that's going to give me 16. And the bottom is a 16. So now my numerator has been to what you call simplified to 16. My denominator, all that at the bottom, has been simplified to a single number, 16. And 16 over 16 is just simply 1. So all this is the same thing as just 1. Okay. Debating if I should do more or leave you to actually try to figure this out. Let me do 5. Okay, 5. Let's do 5, 25. We'll do the inside the parentheses first. Minus 4 to 2nd power is 16. That's all going to be to the 3rd power. Minus 18 divided by 1.5 times the decimal 2.4. 25 minus 16 is 9. I'm going to take that 9 and raise it to the 3rd power, and then we're going to do 18. And again, I'm doing it this one by one. 9 to the 3rd power is 9 times 9 times 9, and 9 times 9 is 81, and 81 times 9 is going to be 729. Minus 18 divided by 1.5 times 2.4. What do I do next? Well, this is gone, the exponents are gone. Now I do multiplication or division. So division came first in this particular case. So I'm going to do that first. 729 minus an 18 divided by 1.5, I believe is 12. So 18 divided by 1.5 is 12. And then 12, I still need to multiply that by 2.4, which I'll do next. So 729 minus 12 times 2.4. I have no idea what that is. And we'll find out. That equals 288. I can now subtract both. And I get a final answer of 441. Okay. So I'll do 2 out of the 4 and leave the other 2 for you guys. Translate each sentence to an algebraic expression. Okay, this is, just it's been a while since we do this. So 1/3 of a number, well, literally translated, 1/3 is this. Of means multiply. And a number, we don't know, so let's just write in. There you go, 1/3 of a number. So you're taking 1/3 of whatever that number is. 8 times the sum of a number and 5, so 8. I like to do where we translate literally right under it. 8 times, what are we multiplying? The sum of a number and 5. So it's sum here, okay? So basically you have to add that number and 5 and then multiply by 8. So we need to protect that, because if we write sum, well, sum is addition, right? Of a number and 5, and we leave it like this, if you follow order of operations, you would have to do 8 times n first and then add to 5, which is not what we want. We actually want to add these 2 and then multiply by 8. So parentheses in this case is definitely necessary. Okay. 11, 9, 11 less than twice the number. 11. Okay, 9. 9 is 9. Less than means subtraction. Twice means 2 times. 2 times what? 2 times the number. Remember here, please, less than is a turnaround word. So we're going to switch the order. It becomes like that. Okay. 12. Notice that this one I'm doing everything. The quotient of a number and 5. Quotient is division. So remember I told you I'd like you to use fraction as a division. Okay, we're using fraction. So quotient of a number and 5 increased is plus by 4. Okay. Substitution. I don't want to do all of it. Well, let's do 13 and maybe 15. I'll do 2. So let's substitute first. So every time you see an A, you're going to replace it by 4. Every time you see a C, you're going to replace it with 6. And every time you see a B, you replace it with 3. So let's do that first. So remember, anytime you have a letter, a variable, or 2 variables next to each other, they are all being related by multiplication. So that literally says 2 times A times C minus B squared. So let's do that. 2 times A, and A is 4, times C, and C is 6, minus B squared, so B in this case is 3, to the second power. There's your substitution. We have done nothing but substitute, so let's take care of this now. It's order of operations. We can actually multiply these at the same time. We're going to do 3 to the second power. 2 times 4 is 8, times 4 is 8, and 8 times 6 is 48. So these 3 numbers is 48, minus 3 to the second power, please. It's not 3 times 2, it's 3 times 3, okay, which gives us 9. And that whole thing is going to give us 37. Okay. I don't know. 15, did I say 15? We'll do a 15. Well, 15 looks like 13. Let's do 14. Right? 14, BC plus 3A, so BC, so it's 3 times C, which is 6, plus 3 times A, which is 4. All that over B, which is 3, plus 2. So that's what our fraction looks like with substitution. So let's change things around. So let's work on the numerator. On the numerator, we got 3 times 6, which is 18, plus 3 times 4, which is 12. And our denominator, we got 3 plus 2, which is pretty simple, 5. 18 plus 12 is, I don't know, 30. 5 at the bottom stays the same, and 30 over 5 is 30 divided by 5, which is the same thing as 6. Okay. I'll leave the other 2. So this is one of those where distance formula. Distance, every time you want to find a distance and you have how fast you're going, and you have the time, we can calculate it. Okay, so it's just remember we also had formulas that we did where we changed the temperature in Fahrenheit to Celsius. So that's another formula. Formula is something that you can use it over and over again to find certain things like distance. So let's see how far this person traveled. Okay, so the distance that we want to find. Distance is rate. So the rate is the speed here. He was traveling at 95 miles. That would be 95 miles in what? In an hour, right? Times 180 minutes. This question is a little tricky because the speed is given in hours, right? 95 miles per hour. When you multiply this, whatever you multiply this, the time should be in hours as well. So notice that the minutes, so notice that this time here is given in minutes. We're going to have to change the 180 minutes to time. I know that 60 minutes is 1 hour. So I can write it like this. 60 minutes, 1 hour. I can create a ratio. Okay. And then I can create something, a proportion. So minutes on top, hours at the bottom. So, and 180 goes on top, right? Do you see a relationship? Yes, there is. 60 times what's 180? Times 3. So at the bottom would be times 3. 1 times 3 is 3 hours. So 180 minutes is the same thing as 3 hours. So you need to change that 100 to 3. So the distance that this person traveled, assuming that he kept the speed of 95 miles per hour for 3 hours, it'd be 3 times 5 is 15. Carry the 1, 27. 285 miles. That's how far he went in 3 hours. But the tricky part here, you have to make sure that you change that minutes to 2 hours. Okay, because otherwise you would have been, you're multiplying 95 times 18. Okay, and that would have given you 1,710 miles in 3 hours. And if you got that and you left it as it is, you should have at least stopped, because if you can only travel 95 miles in 1 hour, how is it that you can travel 1,710 miles in 3? It's way too much. Okay, something should have been telling you stop. Okay, there's something wrong here. So the trick is to change this 180 minutes in 2 hours. Okay. Okay, so this is something that we did today for some of you. The length of a rectangular desk is 3 more than twice the width. What is the length of the desk? So, not asking for perimeter. Remember, perimeter was to add this plus this plus this plus this. I simply want to know, what's the length here? Okay, so it says that the length of the desk, this is your desk, the length here, this part, or this part on top, to find that you have to do 3 more than twice the width. There you go, 2 times the width. So there, what is the length of the desk? The length of the desk is 3 plus 2 times whatever the width is. So if I told you the width was 5, so 5 inches right here, well, you go 3 plus 2 and substitute the W by 5, and you get 3, and 2 times 5 is 10, which gives you 13. So the length would be 13 if the width was 5. But since we don't know what the width is, here's your length. Okay? What's going on? Identify the number of terms, coefficients, variables, and constants in an expression. Okay, so a while ago, not too while ago, we discussed what terms were. Terms are parts of an expression, and the terms are separated from each other either by an addition sign or subtraction sign. Think of them as our commas. Okay, just like we go to the supermarket, you buy apples, comma, carrots, comma, I don't know, pairs. That comma there separates the items here, and I know that I bought 3 different things. Okay, so my list, my shopping list here is made of 3 things. So an expression, to find out the number of terms in an expression, think of, you can even rewrite it. You can write 4, comma 12, comma 7h, comma y. How many items are we talking about? How many terms? 1, 2, 3, 4. So this has 4 terms. Coefficients. Coefficients are the numbers in front of the variables. So the coefficients in this particular expression, the numbers in front of the variables are the 4. I have another one, 7. And I have another one, even though we don't see it. Right in front of y, there is a 1. There are my 3 coefficients. Are there variables? Yes, they are. Yes, they are. No, yes, there are. Variables, I have a k and an h and a y. A k and an h and a y. Are there any constants? Any numbers all by themselves? Yes, there is, right here, at 12. And that would be my cost for that expression. Okay. This will definitely show up some point somehow where you have a situation where you have to translate that situation to an expression. Okay, and then use that expression to come up with your eventually your answer. So Sally's renting a private room in the restaurant for her birthday. The restaurant is charging her $285 just for the room. And they also are going to charge $35 for each guest that shows up. So I guess that makes sense if you're going to rent a room at a restaurant. Okay, because they got to block it off. Nobody else can use it, so they got to, they got to charge a fee because otherwise they could have used it for other customers. So $285, and they'll rent it for you. So whether 0 guests come, whether 50 guests come, the room is going to be $285. So you're paying that no matter what. So for sure, and we can write here that you're going to pay $285 no matter what. Are you paying anything else? Well, it says here that they're going to also charge $35. And maybe the $35 is probably for the food. Okay, so the guests have to pay for the food. So you're going to pay $285 for the restaurant room, the room at the restaurant, plus $35 for each guest. And how are we going to, how are we going to represent that? Well, it's going to be 35 per guest or times every guest that show up, right? So if you have 1 guest coming, it would be $285 plus $35 times 1 guest, which is just $35. So you would have that. If you had 3 guests coming, it would be $285 for sure, plus 35 times 3. If you had 10 guests showing, it'd be $285 for the room, plus 35 times 10, right? Because it's $35 per guest, and then you would add these 2. Okay, so here's my expression for the total that Sally's going to pay. This is the expression that she can use at the end of the night to calculate how much she's going to pay. So that's the expression. Now it says 27 people are coming to the party. Okay, so let's calculate. So you're going to do 285, and then you're going to do $35 times the number of guests, 27. So now you can use order of operations to solve this. You have to multiply, right? So we're going to leave the 285 alone. We're going to multiply 35 times 27. That's going to give us $945. Okay, and now you're ready to add those 2. And that gives us a grand total of $1,230 for your for her birthday. Okay. Use a property to create an equivalent expression. I'm going to leave 21, 22, and 23 alone. The last 2 here are exponents. So 2 to the 6th power does not mean 2 times 6. It actually means that the exponent 6 is telling you to multiply the base 6 times by itself 6 times. So it's 2 times 3, 4, 5, 6. That's what it is. So the expanded version of 2 to the 6th power is 2 times 2 times 2 times 2 times 2 times 2. 2 and 2 is 4. 4 and 2 is 8. 8 and 2 is 16. 16 and 2 is 32. 32 and 2 is 64. And that's our answer. Again, here on this one, 2 over 5 to the 3rd power means the base, and the base this time is this whole thing. So you're taking a fraction 2/5, you're going to multiply it by itself 2 times. I'm going to multiply by itself one more time. It's 2/5 times 2/5 times 2/5. So in multiplication of fractions, you multiply all the numerators with the numerators and all the denominators with the denominators. So 2 times 2 is 4. 4 times 2 is 8. So on the top we get 8. 5 and 5 is 25 at the bottom, and times another 20, another 5, you get 125. And we can leave our answer as it is. Okay. So again, this is like a review of a review. I'll give you definitely more next week. Okay. And that's that.